Very well, everybody. We're going to go over how is it that we can use the store memory in our TI-84 for us to solve problems like this that they have to involve loss of exponents or exponent rules. Okay, so the problem that we have is which expression is equivalent to 45 m to the negative 6 p to the second power v12 over 15m to the negative 2 p8 v to the negative fourth for all values of m, p, and v where the expression is defined. So what we are going to do is that we are going to start by storing values for the letters n, p, and v. And we're going to stick to the numbers 3, 4, 5. So how do we do that? First, we're going to store the number 3 in the letter M. So we're going to press the 3 key. Then we're going to press this key right here, store. And then we're going to press the alpha key. The alpha key is just letting us know that we're going to use everything in green, which are the letters. And in this case, we're going to look for the letter M, which is in the division sign, M right there. Very good. And then we press enter. This is letting us know that the number 3 is storing the letter M. Very good. Now we're going to store the number 4 in the letter P. So we're going to press the number 4 and we're going to press store. And again, the green key, the alpha key, for the letter P, which happens to be on top of the key with the 8. So P, enter. So I store a 4 in the letter P. And the last number is going to be 5. Now, 5, we're going to store it in the letter V, which happens to be on top of the 6. V, enter. The reason why we do this is that now we're going to find the numerical expression of my expression, the 45m to the negative 6, etc., etc. Okay, so the way that I'm going to do that is I'm going to type first the numerator in parentheses. So open parentheses, 45. Remember, I need an m, so I'm going to put alpha m to the r caret negative 6. And then arrow out of the exponent. Now we have p to the second power. So I'm going to put alpha p to the second power. This one just put the second power. The last one is the letter v. So I'm going to put alpha v. And this one is to the 12th power. So exponent 12. Get out of the exponent. Close my parentheses. Very good. So all this is my numerator that is divided, and I'm going to type now all my denominator. Open parentheses, 15, m to the negative 2, so I'm going to press alpha m, letter M, exponent, negative 2. Remember, we're using negative, not minuses, okay? Get out of the exponent. Now I have a p, so alpha, and then p, which is the number 8, to the 8th power. So exponent 8. Get out of there. At last, we have a v to the negative 4. So alpha v to the exponent negative 4. Get out of there. And we're going to close the parentheses. So we're saying all my numerator divided by all my denominator. You press enter, and this is always going to give you a number. This might be a very large number, like in this case, but we're just going to remember it. So it's about 1,379,000. The idea is that whichever of these expressions that we have right here has that value, that's going to be my answer. So I'm going to start checking on A. We have 3v to the 16 over, 3v to the 8 over m to the 8th, p to the 6. So we're going to start with open parentheses and type my whole numerator. 3 alpha v to the 8th power. Get out, close it. Okay? divided by m, so open parentheses, m to the 8th. Very good. Get out of the parentheses. Alpha p to the 6th power. Get out of there. Close your parentheses. Enter. So you see how we got a very different number? We're looking for this number. So that I already know that A is not my answer. So now we're going to try B. 3v to the 16. So we're going to open parentheses. 3 alpha v to the 16. Get out of the exponent. Close your parentheses. Over or divided by m alpha m to the 4th power out of the exponent, p, so alpha p, which happens to be the 8, to the 6th power out of the parentheses, exponent, close your parentheses, enter. You see how this is exactly the same number as before? So that tells me that my answer is actually B.